in it. I've done some more for clarity. I've taken this is the static forecast. You see static here, it was a straight line. You cannot just make out very good from here. So I've used a static forecast where all the randomness has also come, your seasonality and all. And you can see still with all the seasonality and all, your data is lying within the confidence interval. It will not, it is not going out. So your forecast is a good one. I have done it little further. Okay, so if your forecasted data is overlapping with your actual data, you have a good forecast. That also I've shown it here. You can see your data is completely overlapping with your forecasted data. So you can use it for further prediction. Okay, so this is also done. I have shortened the data to show with a near result. This is for all the 16-20 years we have taken. But here I have taken the last 5 years so that you can more clearly visualize the data over the past 5 years. And you see this blue one is the actual data and this is the forecasted data. They are trained, everything is going together, so you have a good forecast. So you can just extend it further and know what is going to happen in the next year. So I have plotted here for 2020. So if you extend that line, 2020 thing will be forecasted. So you can use your prediction, your estimated model of the ARIMA to forecast for the rest number of years. Here only for 1 year I have shown. You can do it for the rest. So coming to data speaks silently. We have to infer it loud. So using all the test and all. So this is what the ARIMA gives you. You know, this is auto-regressive. We have used a case where one value is regressing about its own past values. Time series have many other techniques. So like your cross-section, you can use regress it over different variables also. Okay, like your VAR model is there, BCM model is there, which use other variables as independent variables. That is something which cannot cover. Am I audible?
Yes, ma'am. Yes,
okay.
ma'am.
So what we are going to do now, go to the EViews and show a little bit of it, if time permits. Praveen sir allows. Let me know whether you are able to see my EViews. Are you able to see my EView screen? Are you able to see my EView screen?
Yes, ma'am. Yes, ma'am.
Okay. So whatever we have done, okay, something which easily you cannot maybe making out. Let us run how much time permit. We'll do it here a little bit. This is the first screen which appears. Okay. So what you are going to do here is just close it. This second screen will appear. All the pics, everything I've sent it there. What you do is go to file. Now import the data. Go to file, import the data. So I have kept it here. Wherever you have kept, you can go browse and find. So I have kept it here. If I open, this dialog box will come. Okay. So my data is in sheet 4. You can see here, if your data have more than one sheet, you can also choose from it. Say sheet 1, sheet 2. My data is in sheet 4. So I have kept it sheet 4. Next, if your data is in sheet 1, that also you can change here. So I'll do next. One thing back is, see here, my data are column wise. Sometimes you get the data time series which is row wise. You can also check this box here down and show that you can, you want to, this EViews to read the data row wise. You can check it here. My data is column wise, so I need not check here. So I go next. Here, you have to specify in this box description time series. Do it time series. So here, after doing that, just go to next. Everything here, if your data is monthly, quarterly, you can change all these options here. Okay, my data is annually, yearly data. So already annual has come by default. I need not change. This monthly and all, date wise also for stock markets, you can do it date wise also. You have to change the things here. So it is annual data for me. So I have kept it intact. Here you can rename your series. In that case, you can save it in the EViews. Next time when you open, you need not again go and import the data. It will be here only. You can rename and keep it in the EViews. Save it in the EViews. So I finish. This will come this screen. You click yes. So it is imported the data. It has imported the data here. I hope all these are visible to you. Fine. Just a moment. I'll show you some basic things. So just let me close the screen once. Let me just import the data. So let me take the data from here and create one. I'm just adding one more sheet here, so that's taking time. Just can also do it done here also. So what I have done is I've done the analysis on the FER, so I've just copied the FER data. That's the thing. So just let me delete this part. Whatever time permits, we'll do this. So these are my FER data, because I have done whatever thing has been shown here. It is with the FER data. So let me just save it. is there. So I'm redoing once. Okay. So we go to file, we go to import, then we go to import the file, go to the data here, then this is my sheet file. Yes, this has come. So just we can proceed. So this is time series. So I had imported that FDI data, but we have worked out with the FPR data, so that's why I just changed it so that you can tally with the graph. Otherwise, all different graphs will come. So moving on, everything is same. And next, then we can go for finished. Yes. So now you can see the FPR data is come. So you can see this data. You can click and see the data. It has come. Am I audible? Am I audible? Okay. So next is what we are going to do is we go to quick, then we go to your graph, and here see by default FPR is coming. Otherwise you can also just, because I have selected it is FPR coming, you just do OK. Line and symbol is selected by default. You can go for other options also. Okay. Then you do it's OK. So you see that same graph I had shown you. It has come. I just changed. I had copied the FDI file, so I had to change it. Otherwise, it will not tally with the thing we have done. So just for your understanding, I have changed the file. So FPR, you can see it's the same plot we have used. So it shows non-stationary in the data. You can write the commands. Then this we will do with your ADF test. So what we are doing is quick, then series statistics. You can see here unit root is there. Go to unit root. Okay, there you write FPR and click on OK. Okay, now it is asking you, you want to differentiate now, second difference, first difference, or at level. First is we'll do at level and show you that the data is stationary and it is being supported by the ADF test. So what we'll do is we'll keep the default level and just click on it. Okay, so you see the result which I've given you in your this PPT. Its probability is greater than 0.05. So your null hypothesis is FPR has a unit root which is being rejected. Okay, so now the data is non-stationary. Okay, now what we are going to do is we have to make it stationary. For that, what you have to do is you have to difference it. For a first order difference will go. Same way you will go to quick series statistics, go to your unit root, FPR you type. Okay, this is one way. One way of doing. FPR you type and click on OK. Now it will ask you again the same option. You select first difference. Okay, so you can do it OK, and now you can see second first order difference. The data is non-stationary. I showed you it is in the PPT that first order I didn't get a stationary data. The ADF test is showing that. You can also plot it and see. Okay, there is another way by which you can do the same. But before that, let me show you the second difference. Then I will show you another way of doing the same. See series statistics. Then it's variance. Unit root. Now FPR same. Okay, and OK. Now you go for second difference. Second difference. You see there is no other option for third and fourth. I said beyond that you cannot do. If you do, you lose your data. You cannot do. If it is not EViews, you use some other software. In that case, you lose your data. Say Excel and all. Even if you do, now you see the data has become stationary. See the p values. So now you can reject the null hypothesis that your difference, the FPR data has the non-stationarity. Now it can be rejected. Okay, there is another way by you can do the same. What you can do is quick. Here you can do generate series. You can see generate series. You can go to generate series. There you can create a series. Instead of going to the other way, you write DFPR. Okay, so this is a new variable I'm creating. DFPR is equal to, this is D bracket FPR. So what I'm telling is you create a new variable which is the first order difference of this series. So everything remains same. I do OK. You see this variable is being added. Okay. So this variable is being added. So I can do the same thing. So what is the importance of this? Here again and again you will choose the level, but this variable is not there. Again, if you want to revert back and check something, this variable will not be there. But if you generate the series once, this variable is there. Whenever you like, you can click. Now if you just click and do the same, select the difference, same way you go. And no, let us create the second difference also, because our data is stationary in the second difference. So let me create directly the second difference also. I write it DDFER. This is according to the 50 also, equal to, this is D of, now I put the bracket, see very nicely, otherwise it brings the variable. Bracket, now this is D of FER, because I'm taking the second difference. So I've created the second variable. Now you can move on. See, this is my data. And you can see from the beginning, two things are being left blank, because second difference means two data I have lost. Okay, two data I have lost. So that's why beyond second difference you should not go. Now I'll go for the SCF and PSCF test. So what I do is go here, then see a series statistic, quick series statistics, then go to parallelogram. Okay, there I'll do DDFER, because the second difference thing we are going to use. Okay, so I did here, type the name. It is asking level, first difference or second difference. Remember, already I have taken the second difference. If you do first difference, that means it will take the third difference. Okay, so you have to keep, because I'll take FER only, then here I can choose second difference. But because directly I have created that variable, I have taken DDFER, that means already I have taken the second difference. I will keep this at level only, because here if I choose first or second difference, it will go on differentiating further. So you choose at level and do OK. And these are the spikes you get. Okay, so you see the same diagram we had in the PPT. Your AR is showing one lag, and PSCF is also showing one spikes. All other spikes are within the dotted lines. So there are no autocorrelation of a problem with this. So you have your correlation problem with only the first lags. Okay, so you have a autocorrelation. Remember, your PSCF will determine the lag order of your AR, and SCF will determine the lag order of your moving average, the MA part of your ARIMA. And your integration in this case is 2, because we have taken the second order differentiation. Is it understood? Is it understood till here? Am I audible? Ravin sir, you let me know when to stop. Am I audible, sir? Hello?
Yes, ma'am. You can stop within 5 to 10 minutes, maximum
Okay.
10 minutes.
Okay. So if I show you the plot of the FER, you can see we go by the same way, quick. Then we go for your series and parallelogram to check the SCF and PCF and do OK. This is at level. You have to take it. We are doing the raw data. So you see that same diagram. So you can see there is a lag up to the 8th one. After that, it has gone in between. So there is a lag up to the 8th one, and this partial autocorrelation is showing the only lag for one period. All are within the bounds. Okay. From here, you can go for further estimating the equation and forecasting. Okay. So if any question you can ask.
Participant, if anyone having any question, please ask.